So good morning, everyone. It's a pleasure to be here. I'd like to thank Russ Davis and everyone that organized this event. I'm from the Federal Institute of Technology of Alagoas, and I'm a leader of the research group SECO, where we work with usable security and privacy for ubiquitous communications. Go ahead. So I'd like to speak firstly about IFAL. It's a new institution. It was founded in 2009. The idea of IFAL is to provide courses in the levels of high school, undergrad, and graduate levels. IFAL is focused on science and technology, so we don't have courses from other areas such as health and law yet, but mostly of our focus has been on technology historically. We do research and development, mostly engaged in application for technologies in society. So we're trying to improve society through science and technology by trying to get practical problems solved. Our aim, there's just a minute, please. There's something wrong at the well, there's, I guess the image is not very clear, but I can. Yeah, okay. So well, our aim is to keep a close relationship with the industry and companies because we're trying to solve real-world problems doing research and development. Go ahead, next slide, please. My research group, SECO, was founded last year. We have 2 professors and 6 students, researchers. Right now we are developing research and development in the fields of usable security and privacy, persuasive technologies, and emergency and community mesh networks. I'm going to present a few of these projects that we're working now in a few minutes. The idea of working in these fields, they're pretty much novel fields of research. I'm going to show you afterwards, but the idea is that these areas, these novel areas, they seem to be a direction to solve several of the challenges we face today in terms of security and privacy on the internet and in several other scenarios. Next slide. So why usable security and privacy? Let me try to put it clear. We have a lot of unusable security and privacy. That's the problem. If you take a look at today's scenario, if you were able to see Russ' speech last introductory speech for the event, we have a number of privacy and security issues. We have a lot of phishing going on and successful phishing of websites costing billions of dollars. Lots of compromised PCs and user privacy. Lots of information leaking. This doesn't seem to have an end. So why is that happening? Because if we take a look, there's a lot of, you can move on to the next one. Next slide. We have a lot of cases, for example, in the Brazilian media. We've been announcing that the US is now spying us, and that there's a lot of compromising of the privacy of famous people. We have a famous case here of an actress who got the pictures leaked on the internet, and actually it was a good cause for creating a law for trying to arrest those criminals that compromised the information of this actress, for example. We had another case for another actress. And anyways, why is this still happening? Because we do have lots of security and technology going on that could be used to stop this kind of incidents. Go ahead. Well, I think there is something wrong at these slides. Just a minute, please. Tem alguma coisa errada aí. Na conversão. Advance. Okay, so despite the fact that we've got strong, for example, strong end-user encryption, we've been, for example, into PGP since 1991. That's a long time. PGP was created actually to preserve user privacy. We have another example. We've got open source strong encryption software for hard drive encryption. Why isn't everyone using this? Because they exist. This kind of tool should be very useful for preserving user privacy. We also have firewalls, sandboxing, intrusion detection systems. None of this should be seems to be working because we still have lots of incidents at the user side. So the weakest link is certainly the user. Most of the attacks that are successful today are on the user. So the idea is, how can we preserve, how can we prevent that? So the grand challenge is, given users security controls they can understand and privacy they can control for the dynamic pervasive compute environments of the future. So this kind of challenge is what we're trying to achieve. So in our group, we're in the direction of why not behavior change? If users don't seem to care about security, which is the feeling of many professionals in the field, users simply don't care about security, that's why they get so much compromised. What about if we try to improve their behavior regarding security? So the persuasive technology field is about exactly this idea. How can we manage to try to change user behavior? Can they be persuaded to change their behaviors towards more secure behavior, or towards using secure tools and technologies to improve their privacy and security? So we believe so, and this is a very big research challenge we're tackling right now. Next. So we have this project, Preserving Privacy on the Internet, a persuasive technology approach. It's initially funded by IFAL. It started this year. It's very recently. We still have no initial results because it's very preliminary right now. We're looking for sponsors and partners because this is a project that can be very big. Go ahead, next. Our second project is also funded by IFAL. We are doing more like a community project in the context of community mesh networks. How could we provide last mile access to the internet using wireless technology? So mesh technology is a good tool in this direction. I'd like to shortly explain what exactly are they. So mesh technology, they're a kind of organic, self-organizing network. We can provide communities the ability of having their own infrastructure to network locally, and then they could connect to other backhaul access connection to the internet, for example, or even share among them this internet connection. I'm going to show you a few scenarios. Go ahead. So just to understand exactly how it works, we're considering a multi-hop wireless network, which means all the nodes work together. It's a distributed network where we can transfer packets from one machine to another until its destination. The next speaker should make it clear. Go again. Okay, so in this scenario, you have several mesh routers, equipment that is working exclusively to route packets among this network. See, they're working together in order to provide access to the other nodes and the other networks which are connected at each of these routers. And up there's a connection to the internet, which could be very much shared among all the users and all the other networks. Sorry. Go ahead. This is an example of an infrastructure backbone. There's another scenario where you can do simply independent connection and independent mesh network among nodes. So you don't have a central infrastructure in this case. It's also a case for mesh networks. again. The third case could be a hybrid. You could have a bit of infrastructure and independent networks which connect to this infrastructure. Go ahead. Just a moment, please. Okay. This kind of network is one of the most appealing scenarios. Is the emergency one. Given that possibly in a disaster scenario, most of the actual infrastructure is unusable. You won't have cell phones. You won't have anything except maybe your mobiles. You could assemble an emergency network using this kind of technology. Go ahead. Sorry about the delay, but okay. So these are other scenarios in the emergency context. You mean you could coordinate a fireman work. I'm sorry, and because you're naturally this is the kind of network that is possible in that scenario when you don't have infrastructure, when it's been destroyed. Military scenario would be very much welcome to mesh networking. So all you need is, we have several applications. We need research to make this network fully functional. There is a very strong related project we are partnering. Is the Australian project Servo, and they provide their own solution for mesh networking, but we're trying to use their solution to experiment, to get a feeling of the technology, of how it behaves in a practical scenario here in our state. The other technology we're working with is the Mesh Potato, which is built by the Village Telco project. It's an open source hardware and software, which runs an embedded version of Linux, as well as Batman, which is the routing protocol, and Asterisk, both are open source software, would have a long reputation of stability and quality. Go ahead. I'm going to just show the equipment that we use. This is the Mesh Potato, the older version. Another equipment we use. Go. The Ubiquiti Nano Station. This is two equipments we work for building this kind of network. So what are the research challenges in this network? Mostly there is an untapped area. Security and privacy in wireless mesh networks hasn't been very much explored. The usability of these technologies have not been very much studied in the literature. We can have a lot of room for performance improvement because you have to attack many layers. And from the physical layer to the application layer, you can have a performance improvement in this kind of network. So these research challenges are what the project intends to address, to study. We have some current partners. We have professors from the university itself, IFAL. Rafael Morim, Fábio Paraguaçu, their masters and PhD. We have people, last presenters from the last presentation about IFAL, Leandro Salles, Rodrigo Peixoto from CompLab, and we have from IC4MF and Hastru, Ross Davis and Alencar. Go ahead. We're establishing a partnership with IC4MF in order to cooperate and provide forensic tool training and certification, and as well as prosecution support via DEFC, which is another organization linked to IC4MF. Okay. These are some references for those who got interested, and that's it. Thank you very much.